Okay, let's continue. So in the first part, we were mainly talking about local browser automation infrastructure. And now in this part, I will mainly be showing you how you could deploy the same solution to a cloud platform, how to deliver a remote browser automation infrastructure. So in this part, you are not expecting to repeat everything I'm doing. So just take a look if you are interested. Okay. So first of all, just to understand what we will be seeing in a few minutes, let me explain you how Kubernetes works. What's the main advantage of Kubernetes? Because I think you would agree that the overall browser automation infrastructure cost is one of the main reasons, one of the main parameters that is being considered when deciding what solution to use. And in case if you are using Kubernetes, you are out of the box are getting a feature called Autoscaling, because if you are using any cloud platform, public cloud platform like Google Cloud, Amazon Web Services, Microsoft Azure, DigitalOcean, and so on, Kubernetes there is running on top of standard virtual machines. So when you launch the cluster, you have only a limited set of virtual machines running. And when your tests start to request more and more browsers, this Kubernetes cluster can automatically scale. That means it can automatically grow when you need more browsers. And this is done by automatically launching more virtual machines in the cloud. The Kubernetes cluster itself requests more virtual machines to be launched. This is done automatically. And after running your test, this cluster can also downscale. So usually after some idle time, like 15 or 10 or 15 minutes, depending on the cloud platform, these virtual machines start to shut down, and your cluster returns to the same state it was before. This allows you to economize a lot of money for browser automation infrastructure, because as I said, browsers are consuming a lot of memory and CPUs while running. So the next thing we need to talk about is the ways you can use to get the Kubernetes cluster. So in the first part, we were using the Minikube tool, which is a standalone binary that allows to automatically launch a cluster locally. In big companies, usually teams are deploying Kubernetes manually. So there is a dedicated team of DevOps engineers who is reading the Kubernetes manual attentively and is deploying everything manually on top of a set of hardware servers or virtual machines. And the third possible approach that we will be using now is the cloud platform. In that case, in the cloud platform, you can easily create a Kubernetes cluster with a few clicks in the user interface. And as I said, it will be running on top of standard virtual machines. So finally, before I start deploying things, let me show you how a truly reliable cluster in Kubernetes platform should look like. So first of all, to be reliable, this cluster should be running in 2 or more data centers. And in every data center, you should have an instance of Selenium solution of Moon in our case. And so far as we have two separate instances called replicas of Moon running in Kubernetes cluster, we need a load balancer just to load balance their requests for the browser sessions. And this load balancer is usually delivered by the cloud platform. It's automatically created by the cloud platform when you request it. And this load balancer also delivers a permanent IP address to access the cluster. So if, for example, you need a, how to say, a beautiful domain name like moon.example.com for accessing the cluster. You can just ask your systems administrator to create a respective DNS record pointing to this IP address of the load balancer. And in order to economize money, by default, only these machines with the Selenium solution are running in the cloud platform and the load balancer. When you start requesting the browsers, because of autoscaling, several more bigger virtual machines with more CPUs and memory are automatically created in the cloud platform. And these machines are being used to run the browsers. And that means that your overall cluster cost will have two different parts. The first part will be a constant part. That means the overall cost of these small virtual machines with Selenium solution plus the cost of the load balancer. And there will be a variable part that will depend on your cluster usage pattern, because I think you would agree that in companies, usually tests are mostly being executed during the work time. Sometimes you are executing the tests during the work days at night, and you are not so frequently executing your tests during the weekend. And because of autoscaling, in case when you're not running your tests, for example, during the weekend, you will not be spending your money for these big virtual machines because they will be automatically destroyed by the Kubernetes cluster. So that's the motivation and how it works, how the big cluster works in the cloud platform. And now let's start deploying things. So these were the requirements of remote browser automation infrastructure. So the first thing we are going to do, we are going to create a Kubernetes cluster in the cloud platform. So in my case, I will be showing everything in Google Cloud, but you can use any cloud platform because all popular cloud platforms are having a Kubernetes support right now. I just have more experience with this one. So I'm opening the Google Cloud. I'm going to this section called Kubernetes. I'm just going to Kubernetes here. I'm going to clusters, and I will now create a cluster, Kubernetes cluster in Google Cloud. So I'm clicking on create cluster. You will see that it's rather straightforward stuff, creating a cluster, Kubernetes cluster. You just need to do a few clicks. So I'm typing some name like test cluster. I can, for example, choose a zone or region. That means a geographical location where my cluster will be running. So I can leave the default settings here. And the most important setting for Kubernetes is the configuration of nodes. That means the virtual machines that will be running, that Kubernetes will be using to run. So we need to specify, first of all, the default number of the virtual machines being used by Kubernetes. Let's leave 3 virtual machines here. And the second thing we would like to enable here is the autoscaling feature. So that's what I was showing on the slide. We will configure our cluster that it could grow from 3 nodes up to, for example, 5 nodes maximum. And this setting usually determines the final cost of computing resources in the cloud platform. So I enable the autoscaling here, and the last thing I need to specify is the type of virtual machine I will be using for the cluster. Here, we recommend using bigger virtual machines, for example, with 4 vCPUs, at least 4 vCPUs, just because browsers, as I said, require at least 1 vCPU for every browser instance. So having specified all these settings, we simply click on create. And now we need to wait several minutes for the cluster to create. Just it takes some time to launch the virtual machines, to download, to upload the software to the virtual machines, and so on and so forth. So let's take a look at the questions. You are not sharing your screen. Shit. That's not good. Okay, let me quickly show you the slides. Yeah, that's awkward moment when you realize I'm sharing the screen. Sorry, guys. Anyway, let me show you again the slides. So that's the first thing I was showing you, the Kubernetes autoscaling stuff. So I just need to show you that your cluster can grow and shrink depending on the load you have. That was the first one. The second one were the ways of getting Kubernetes cluster. We have Minikube, we have manual installation, we have the cloud, platform that we're currently using. And this is the architecture of the cluster we are going to deploy right now. So here is a load balancer. We have two virtual machines, two pods or containers with the Selenium solution, and we have a bigger virtual machines with browsers that are being used to run the browsers themselves. That's everything related to slides, so hope you understood. And let me show you one more time. How I created the cluster. So I'm just going to Google Cloud, to the Kubernetes engine. I click on create the cluster. Here, I type some cluster name. I type some cluster name. I go to the virtual machine settings called node pool details. I specify the number of virtual machines. I enable autoscaling. I specify the maximum number of virtual machines behind the cluster to 5. And the last thing I did, I specified the size of the virtual machine. So I specified the virtual machine with 4 CPUs here. So then I clicked on create a cluster. That's everything I did, okay? So hope you understood the main idea. But all this stuff you can read in the documentation. It's rather straightforward. Okay, so now after several minutes, we have a running Kubernetes cluster. And we can also go to the virtual machines section of the cloud platform and see that we have 3 virtual machines running here. So there are 3 virtual machines that were automatically created by the Kubernetes engine itself. So we'll need to configure my kubectl tool to just to point to this newly created cluster. How to do this depends on the cloud platform. So for example, in case of Google Cloud, they are providing a ready-to-use command that you can copy paste and execute in the shell. So let me do this. This we can stop. Let me do this. I will just add this command gcloud to my path because I'm not using it frequently. So I'm executing this command. And now I can check with kubectl and get nodes that my kubectl is pointing to this newly created cluster. So I should see 3 nodes right now. Yes, there are 3 nodes. They are running approximately 2 minutes, these nodes, and we don't have a ready-to-use cluster, ready-to-use cluster that we can use to deploy a Moon solution. So in the first part, I was installing Moon using this raw YAML manifests in the Moon deploy repository. Moon deploy. We were using this. Right now, I will show you the second way, second popular way of installing applications to Kubernetes cluster. In that case, I will be showing how to install it using so-called Helm. So there is a section you're using Helm. Sorry, just let me show you how to install with Helm. So Helm, this is a package manager for installing applications to Kubernetes cluster. This is the most popular way of installing applications to Kubernetes, to production at Kubernetes clusters. It works in the similar way, like, for example, the apt or Yum tools under Debian or Red Hat Linux distributions. So you are adding some repository with packages. You are fetching the information with about available packages, and then you can simply install the desired package. So let's simply copy paste the commands from the documentation. We are adding a repository where the information about these packages, they are called charts. This information resides in this charts repository. Then we update the repository information. So just updating, just fetching some metadata. And now we can just install Moon to our cluster. We first of all create a namespace. This is a kind of project in terms of Kubernetes. It's called a namespace. And the last command we need to do, we simply issue this command helm upgrade install. And let me explain what we have here. So Helm is the Helm command itself. That means install. That means install to the namespace called Moon. That is release name. That means product installation name. And this is the package name we are installing. This is called AirKube Moon. So we are issuing this command. And in a few seconds, it should install. So it's in state deployed. We can check the running pods in the namespace Moon, and we are, what the fuck is this? We will see that it's running. It should be running. Yep, it's running. Probably image pull back off was because of some issue in the registry. So now everything is running. In order to be able to connect to the cluster, instead of launching any tunnels, we just need to get a permanent IP address delivered by the cloud platform. So now if we simply list all the services in the same namespace, we will see that there is a service with a type load balancer and with an external IP address already filled by the cloud platform. Usually it takes some time. So here it's running for 59 seconds. Usually it takes like 30 seconds for this IP address to be assigned. And you just need to wait. So it will be saying pending here until the address is actually assigned. So we can now copy this address, and we can simply open the same port 8080, but using this this IP address that we just received. So, and we are getting just the same. We're getting just the same user interface. So we're getting just the same solution, but deployed to the cloud platform. So that was Moon installation to the Google Kubernetes engine with Helm. Okay. Any questions? No, there are no questions. Okay. Somebody's typing. Okay. Okay. So now what I will be doing, I will now show you how to configure so-called S3 support. This is needed for automatically saving recorded videos and browser session logs to S3 compatible storage. So I think some of you could heard about S3. So initially S3 is a protocol that was created added to the AWS cloud, and this is a way to store files in a reliable way. Currently, S3 this is translated as Simple Storage Service S3, and currently this type of storage became a de facto standard of file storage in cloud platforms. And every popular cloud platform has something compatible with S3. So even a Google Cloud has an S3 compatible storage. So we will now create a storage for our recorded videos and session logs. We're just going to storage. So if you are using AWS, you simply go to S3 and create a bucket there. In Google Cloud, we are going to storage, and we will now create a bucket. A bucket is just like a folder where you can store your files. So in order to create our bucket, we basically need to only specify the name of the bucket. So for example, TestJS Summit, we can type here. We continue. We can select a region where we store our data. Usually we recommend selecting the same region. So for example, our Kubernetes cluster is in the United States, and we recommend having a S3 bucket in the same region, because otherwise you will start paying for the network transfer between the S3 bucket and the Kubernetes cluster. Okay, so there are several other options here, but I think we can use the default ones. So click on create, and we will now get a bucket which is empty. The next thing we need to do, we need to get so-called pair of access keys of keys to access this bucket from the Kubernetes cluster from Moon. In Google Cloud, this is located under this interoperability tab. Here, there is a section with an access key, which is a kind of username, and with a secret key, which is a kind of password. So I'm just copying the access key here, and I'm just copying a password. Okay. And now I will simply configure S3 support. And the most important thing is that I will do this without stopping the cluster at all. So you can continue running your tests, and I will reconfigure the cluster without interrupting any tests. So in order to configure, to add S3 support to a running cluster, we only need to issue a very similar command that we did before. So we need to run Helm upgrade install one more time. But the only change we need to do, we need to specify several parameters, several settings. To see these settings, we can see a full list of these settings. We can issue the following command: helm show values and the package name. So there are a lot of values. So there are a lot of different flags here. So they're all under the Moon namespace. There's a flag to, for example, disable resources control, flags for controlling different timeouts, and so on and so forth. So let's search for S3. And we can note that S3 is located under config section. There is S3. And we need to specify several values here. We need to specify the endpoint for accessing the S3 API. We need to specify the bucket name we just created, and we need to specify two keys: an access key, a username, and the secret key, a password. So knowing all this stuff, let's just issue a command to update parameters of our running Moon installation. So I will open one more tab. I'll open one more tab. I will search upgrade. I will search just the same command, and I will start setting parameters. So these are usually set using the set flag. So we set, for example, we set Moon config endpoint equals to, for Google, this is the correct value. You can just take this value from their documentation. We now set Moon, I just forgot S3 here. Moon config S3 bucket name TestJS Summit. Set Moon config S3 access key. I will now copy here. Set Moon config S3 secret key. I will copy one more time. So let's check that we specified parameter names correctly. Seems to be correct. So if we now do an upgrade, we will first of all see that the revision number of Helm has changed to 2. We will see now. Yes, revision number is 2 because we are doing some upgrade for the second time. And that's the first thing. And the second thing that is that if we check here, we can see that our containers continue to run. So our tests can continue running even when we are modifying S3 settings. The last thing we need to check that S3 was actually activated. We can simply view the logs of Moon. We need to view the logs of the application labeled Moon. We need to use the container called Moon and in the namespace called Moon. So in the logs, we should now see no S3 endpoint specified. Let's try one more time. There is an issue in command. S3 Moon config S3 endpoint. S3 endpoint. Let's check one more time. I think we just didn't wait a sufficient amount of time. Yep, we just needed to wait more time to see that Moon is now configured to upload our test data to this bucket named TestJS Summit. And if now we try to run a test, we will see that logs and videos are being successfully saved to this bucket. We will see it a bit later. So this was how to configure S3 support. And let's now see how logging and video recording works when we enabled S3. So we can, for example, take our WebDriver IO test. So we can just, first of all, copy paste the address of the cluster, kubectl, get svc, -n moon. We copy paste this IP address. We go to our settings. We simply replace the host name with the IP address of our cluster. We can, for example, use all the rest. We can use just the same settings. And if we now run the test, after running the test, we should normally see the video and the log. The video is activated like this in capabilities. The log will be updated just by default. And after running the test, we will see that the respective log file and the respective video file will be placed to the bucket. So we go to the browser. We wait for the test to finish. So we open this TestJS Summit bucket. We wait for this test to finish. So far as we are using a clean cluster, it takes some time to download the respective browser image for the first time. Usually in cloud platforms, it's faster, but however, it can take like 30 seconds or probably a minute. So it depends on the speed of network on the virtual machines. And we can see that there is a browser pod being created right now. So it's already terminating. That means that our tests have already finished working. Yes, our tests have finished working. And we should now refresh the bucket and see there should be a session. Yes, this is a browser session we just created. And there should be, first of all, just let me increase a bit. There should be a session log. So you can just open session log here. That's the session log. And there's also a recorded video. Just let me open one more time. There is a recorded video here. It's a bit buggy, their user interface. So here's a video. We can open it using this URL, for example. So you can see that there is a browser, there's a DuckDuckGo being opened inside the browser. That's the test execution video. Here we can also see that we are still using the mobile emulation in the browser. So stuff like this. And usually all these logs and videos, you can, for example, configure your S3 bucket in order to provide, to allow public access to these files. And you can simply attach the URLs to these files to your test execution report. So for example, if you are using stuff like Allure report or test report Portal solution, you can simply attach a URL to these artifacts to this report. So something is leaving, somebody is leaving. Okay, never mind. That was everything related to logging and video recording. And at the end of my presentation, I will show you two last things. The first one is live cluster maintenance. We already seen the stuff. So for example, when we issued this command to update cluster parameters, that was the live cluster maintenance. Because Here you can, for example, pass stuff like you can update the moon image, you can update settings of the timeouts or computing resources, allow it to be used by each browser, and so on and so forth. So when you issue such command, you are changing things without actually redeploying the solution. So all the changes are being applied without actually interrupting your tests. And to show you one more change, for the last step for the autoscaling demo, I will need to make sure that my cluster can run a lot of tests, because you can see that here in the user interface that by default it can only run 4 parallel sessions. This is our like a free tier for using this solution. If you need more, you need a license. So I will now just install a license, moon license key, allowing you to run 50 parallel sessions. So it should be it. That should be it, I think. So I'm applying this command one more time. And after some time, we should be able to see in the user interface that we can now run 50 parallel sessions, for example. So let's check the logs. Yes, we can see here. We can see here that we can now run 50 parallel sessions. I think we should also see this stuff. No, it's not working for some reason. Okay. It's now updated. We can now run 50 parallel sessions. So the last thing I would like to show you today is how autoscaling actually works with Moon. So for just to demonstrate you the autoscaling, as I said, I will be using a Go application. I just posted the source code of this Golang program. I'm just using Golang because for me that's the easiest way to create a lot of parallel sessions. So this is really a straightforward program, 50 lines. That's simply creating a lot of Selenium sessions. So I will just now switch to a directory where I already have this compiled command, and we'll show you how it looks like. So this is a standalone binary, because in Golang you compile everything to the binaries, and there are only several flags to be specified. There is a browser name, there is a browser version, there is a number of tests to be run in parallel, and there is a Selenium URL to be used. So let's try to run this command and launch only one test. We specify browser name equals to Chrome. We specify browser version equals to 88, because we just already have a respective image. We specify num tests equal to 1, and we specify Selenium URL equal to HTTP. Just let's copy paste an IP address one more time. Port 4444/w/hub, and let's execute this command. So we are running only one test, and this command successfully saved a screenshot to this file, screenshot1.png. Okay. So let's now simulate a potential load of your tests. Simply do only one change. We'll replace the number of tests being run in parallel to 50. So we start this program. We'll see that 50 tests are already running. If we now list the pods, we will see that there are a lot of pods. There are 50 pods already. Some of them are in pending state. That means they're waiting for computing resources. Some of them are already creating containers. That means they found some place on existing virtual machines. And if we now list the nodes in Kubernetes cluster, we will see that we have 3 nodes. But Kubernetes, because it has insufficient computing resources, it's already started launching new virtual machines. It takes something like 30 or 40 seconds to launch them. You can see that tests continue to run here. And if we'll list the nodes one more time, we will now see that there are now 5 nodes. That means the maximum number we can have in our cluster. And one of the nodes is running only 10 seconds, another one 11 seconds. And our tests continue to run. They will now finish, I think. And so sometime after I stop running my tests, these additional virtual machines, they will be automatically removed by the cluster. So it should now finish, I think, already. So tests are passing. Yeah, that's finished. And we can see that there are 50 screenshots here, and that's it. So that was the last thing I would like to show you here. Let me show you one more slide just with the URLs. That will be visible on the video. Here is our Twitter, our Telegram channel to ask any questions, our webpage. We also have a YouTube channel where we are usually posting all the videos related to all our tools. And I think this video will also be added there. We'll just add the respective playlist. So let me now try to let me just try to answer your questions. Is the paid solution including hosted infrastructure? No, this is a box solution. This is just a box solution. That means you can install it to any infrastructure you wish. And the only limitation is the number of parallel sessions. So that's the only limitation we have. I think if you're asking about Selenium, so is it a Selenium Grid with a nicer UI? It's not so simple. So Selenium, so far, as I said, is a set of extensions for Selenium Grid, and is basically a stateful solution. So any like fault in the Selenium hub, Selenium Grid will lead to broken tests. And in case of Moon, everything is stateless. You don't need to configure hub, nodes, and so on. So you just launch 2 containers and everything works. That was everything related to, that's the comparison of Selenium. In fact, just if you compare with Selenium, there is an explanation why Moon is stateless. No, that's not it. Yep. Here is a section related to the comparison of Moon and Selenoid, because we're doing both solutions, and Selenoid is more like Selenium. So here is just some comparison how they're just different. What did you have to configure to enable autoscaling in Google Kubernetes Engine, Moon, or in both? I only needed to configure autoscaling on the Kubernetes side. So let me show you one more time. Kubernetes, I'm just going to Kubernetes clusters. I click on create a cluster. So I specify the name, and this autoscaling setting is here in the configuration of the virtual machines I'm using. So I can specify here the total number of virtual machines. So I specified 5 here. So that's the autoscaling setting. And I don't need to configure anything else on the Moon side. So this is only configured on the cluster side. Any more questions? Got test running games when locally, thank you. Okay. Hope it works. Okay, let's wait several more minutes. Just probably someone else has a question. So I hope that this pandemic finishes and we will be able to participate in conferences offline. So if you are interested in somebody of our team, if you're interested in me talking on your conference, I will be glad to join. So just invite me. I can also leave my email address if you wish. So you can contact me by email, because usually there are some shy persons. You can just write me by email if you have any ideas, if you wish to invite me to a conference, if you wish to have a webinar or anything else. So anything, you can just contact me. I see people are typing. So probably there will be some question. Okay, no questions. Okay, thank you for joining. That was for the first time I was speaking. I was just doing a workshop like this in English, just for the first time, and I'm also showing all the stuff related to Moon for the first time. So hope you enjoyed it. Hope. Okay, so just to finish, don't hesitate to contact me. And as you can see, just let me type one more time our Telegram support channel. So you could join right now. There is a support channel like this. So don't hesitate to contact me or to write in this support channel. We are all English speaking, so any question is highly appreciated. So thank you. See you offline in other conferences, because me personally, I'm a bit tired sitting at home. Okay, so I'm stopping sharing. Stopping sharing my screen. And I think I need right now just to end the video recording. Just to at the end, let me say that the video should be published soon, and as soon as I have the access to the video, we would like to also to republish it to our YouTube channel. So hope to have it available on YouTube. So thank you all. See you and bye.